Okay, so let's take a look at this example where we need to sketch one full period of y is equal to 1/5 sine of x minus pi over 6. So let's start off with the amplitude. And we know that this function has an amplitude of 1/5, which means that we are going to, I don't know, why did you just turn red? That's okay, it's very nice to look at that. Which means that instead of bouncing back and forth between 1 and -1, now we're going to bounce back and forth between 1/5 and -1/5. So we're done with the amplitude. We have an amplitude of 1/5. Now, in regards to the period, we can always tell what the period of the function is by looking at the variable and seeing if there's a number attached to it. It isn't. There is no number that's stuck to x, which means we still have a period of 2 pi. If you wanted to think about it another way, you could say, okay, well, 2 pi divided by 1, which is the kind of hidden coefficient in front of the x, which is still 2 pi. So we do have a period of 2 pi. Or our period didn't change from the natural period of the function. Now, in regards to phase shifts, let's focus on our argument over here to discuss what the phase shifts are. Normally, we have one complete cycle of pi that starts at 0 and ends at 2 pi, but that's not going to be the case anymore because we're subtracting pi over 6 from the inside of the function. Now, I want you to think about what it means, and we're going to talk about this in a little bit more detail. But back when we talked about transformations, remember when we subtract a number from the inside of the function, that means we're going right that amount of units. So really what we're doing here is instead of starting at 0 and ending at 2 pi, now we're going to take that interval 0 and 2 pi and shift it to the right pi over 6 units. So our normal or natural starting point at a 0 or natural ending point at 2 pi are now going to be shifted to the right pi over 6. And that's that information that it's giving us. If you take a look at the notes that I gave you, it gives us these mysterious formulas, and it says let's find our two endpoints using bx plus c is equal to 0, and then bx plus c is equal to 2 pi. What this is giving us is this is telling us in order for us to find what our new endpoints are, we're going to take this argument, set it equal to 0, and then we're going to take that argument, the same thing, and set it equal to 2 pi. That will tell us, instead of our old starting place is 0 to 2 pi, that will tell us what our new starting place is with the phase shift, with the transformations. Now, it might be intuitive, that is, you can look at this and say, okay, it's starting at 0, and I'm going pi over 6 units to the right, so now instead of starting at 0, I'm going to start at pi over 6, and that's absolutely correct. We end at 2 pi normally, and now because I have to shift that, pi over 6 units to the right, that means I'm going 2 pi plus pi over 6, 2 1/6 of a pi, which is the same thing as saying 13 pi over 6, which is right as well. But if it's not intuitive to you, the way that you find your new endpoints is by setting the argument equal to 0. That will tell you where 0 is transformed to, and then setting your argument equal to 2 pi, and that will tell you where that right endpoint's transformed to. So let's do that. Let's set the argument, which is x minus pi over 6 equal to 0. Solving for x, we're going to add pi over 6 to each side of the equation, so that's plus pi over 6. And there we go. So we have that new endpoint at x is equal to pi over 6. So again, instead of starting at 0, now we're going to start at pi over 6. And our ending point, which was, let's see, what was our ending point? Our ending point, now we're going to set that same equation equal to 2 pi. So now we have x minus pi over 6 equals to 2 pi. To get x by itself, we're going to add pi over 6 to each side. We're going to add pi over 6 to each side. So we have x is equal to 2 pi plus pi over 6. Let me put this over here. X is equal to 2 pi plus pi over 6. We find a common denominator. We can rewrite these in terms of 6. So that's 12 pi plus 1 pi, which gives us 13 pi over 6. And again, it is kind of intuitive if you want to think about it in that manner that I talked about before, shifting 0 pi over 6 units to the right and then shifting 2 pi over 6 units to the right. So if you take a look now, we have one complete, we have this, pi over 6 is our starting point and 13 pi over 6 is our ending point, as being one complete period of pi. And once you have the starting point and ending point of your period, now we have to find the critical points, or how we're going to parse these out over here. Okay, so now we have our endpoints, we have our pi over 6 and our 13 pi over 6. We have to figure out what the rest of our critical points are. So remember, in order for us to find our critical points, we take whatever the period is, which is 2 pi. We divide it by 4, and 2 pi over 4 reduces down to pi over 2. And we continuously add that to the endpoints. Normally endpoint's 0, but now the endpoint's at pi over 6 until we reach 13 pi over 6. So we're going to start at pi over 6, and we're going to add pi over 2. So pi over 6 plus pi over 2, we have an LCD of 6. That's the same thing as saying pi over 6 plus 3 pi, which is 4 pi over 6, which reduces to 2 pi over 3. So we have a critical point at 2 pi over 3. 4 pi over 6 plus pi over 2 is the same thing as saying, let's do this. We have an LCD of 6, so that's 4 pi plus 3 pi. That's the same thing as saying 7 pi over 6. Ooh, sorry about that. 7 pi over 6. And then 7 pi over 6 plus, one more time, plus pi over 2 takes us to, let's see, here's over 6. 7 pi plus 3 pi, 10 pi over 6. And then 10 pi over 6, let's move over here, plus pi over 2. We know this is going to give us 6. 10 pi plus 3 pi, which gives us 13 pi over 6, which is what our ending point is over here too. Okay, so let's figure out what the graph of this function looks like. We have all the critical points. We know that we're dealing with sine, and remember that sine for the first critical point, sine starts at 0. Sine's one of those exciting roller coasters. So we're going to start at 0. We're going to go up to 1/5. We're going to come back down to 0 again. We're going to go down to -1/5, and we're going to end at 0. And we have our critical points here, so just miss that one. At pi over 6, we have a 0. 2 pi over 3, we have a max. 7 pi over 6, we have a 0. 10 pi over 6, we have a min. 13 pi over 6, we have a 0.